Okay, let's take a look at what we've learned so far. So, the Lorentz transformations and the invariants of proper time have demonstrated that if we have an observer A and a co-moving clock, the clock is co-situated with observer A. So Alice and her clock are co-situated, both at position 0, 0, 0, and time moves forward in proper time. The second thing is that for any such observer, the co-moving clock time is identical to proper time. So Alice's time, because it is co-moving, will only show proper time. The third thing is that a measure of a beat of a clock depends upon the observer. If and only if the observers are in the same identical inertial frame will the beats be of the same length. So if they're co-situated, then they will have the same beats. Otherwise, an observer who views Alice's clock to be changing position, that is, moving, relative to themselves, then they are the moving observer. This is when you read relativity, these are the things you need to understand. Einstein's principle of action states that you should maximize proper time. And as we saw in the previous table, Alice, who's not moving relative to Bob, has a longer proper time than Bob does. This is what Einstein's principle of action means. A couple more conclusions. Alice's proper time, using Alice's time and the space measurements, will also be computed by any observer B using B's time and space measurements of A's position. So if we go back to the table a few back, we see Alice has 0 position, 0 position and time 0.8, that is exactly the same as the proper time. Bob's measure is minus 0.6 and time t equals 1. So Bob, because he's moving relative to A, has time dilation, and that his time is longer than Alice's measurement of Alice's clock. But the combination of time and position provides exactly the same proper time, 0.8, as does Alice, who has no position. So this is the invariance of proper time. And by symmetry, B's proper time using B's time and space measurements will also be computed by any observatory, including Alice, using the Alice's time and space measurements, but provide Bob's proper time being the same as Bob's proper time. And those are the results shown in the last two of the table that we saw preceding. So, do we have any questions? I'm going to pause this one once again.